Okay, we're now looking at question 6, which is a continuation of functions. So the question says, the diagram below shows the graph of f of x, which is equal to minus into brackets x minus 3 all squared plus 25. Okay, so that's our parabola here. And g of x, which is 2 times 1 half all to the power of x plus 1 minus 4. Okay, that's our exponential graph there. And then we told that graph f cuts the x-axis at point A and C, and the y-axis at point E, and has a turning point at T. Okay, and graph G cuts the x-axis at A as well, and the y-axis at B. Okay, so now we have all the information. Let's read the questions and answer them. 6.1. Write down the equation of the asymptote of G. Okay, so G is our exponential graph. And our asymptote, they even marked it here for us, is going to be, let's look at this here again, it's going to be our shift. Okay, so minus 4. So our asymptote is y equals to minus 4. Okay. 6.2, write down the coordinates of D. Okay, so D is our turning point of the parabola, which was f of x. Now, before we continue, let's just talk about parabolas, right? There's 3 different ways that you'll see the parabola function given. Okay, so you first have standard form, right? A of x plus b of x plus c, and this is y equals to that. Okay, or you can have the x-intercept form, so you have y is equal to a x minus b x minus q, or you can have y is equal to a x minus b squared plus q. Okay, this is called turning point form. Okay, this was the x-intercept form, and this is our standard. Okay, so what are we given? We're given the turning point form, right? If you look at this, that's the turning point form. Okay, and what? So let's get rid of this for now then. What do these things represent? Okay, so our P is the turning point. P is the x value of the turning point. Okay, and Q is the y value of the turning point. Okay, so now let's look at the question again. We are asked to find the coordinates of the turning point D. So that means it's going to be 3, right, and 25. Okay, and if we look at our graph, that makes sense. 3 is that side of the y-axis, and 25 is high above the x-axis. Okay, so let's just write this in. 3 and 25. Okay. Write down the range of f. Okay, what is a range? Range is our y values. So if you look at f, it has a maximum point, right? Concave down parabolas have maximum points, whereas concave up parabolas have minimum points. Okay, there's our max, there's our min, and it's the turning point of the graph. Okay, so if you look here, our maximum point is 25, right? You can't go higher than 25, but there's no limit down. You can go infinite. This will carry on to infinity. This will carry on to infinity. Okay, so that means that our range is that y is less than or equal to 25. Okay, because it can equal to 25. That is our turning point, but it can't be greater than that. So it's less than or equal to 25. Okay, 6.4. Calculate the length of EB. Okay, here's EB here. Right? So what are we going to need to find this here? Well, from the looks of it, this is on a straight line, right? EB is lying on the y-axis. So we just need to find what the y value is here and what the y value is here. So we'll call this y1, y2, and then we can just find the distance between them by subtracting that. So let's find those two y values, okay? So point E represents the y-intercept of f of x, while B represents the y-intercept of g of x. Okay, so basically all this question is asking you is to find out the two y-intercepts. Okay, so 6.4 y-intercept x equals 0. Okay, let's start with f of x. So minus x minus 3 squared plus 25. So y is equal to minus x minus 3 squared plus 25. Okay, yep. So if we said x-intercept y is equal to 0, we're going to now replace this x with 0. So y is equal to minus, and then 0 minus 3 is just minus 3 squared plus 25. Okay, so that's going to be minus 9 plus 25. So minus 9 plus 25 is 16. Okay, so that means that this point, this was E, is at 0 and 16. Okay, so let's put that in. So therefore E is 0 and 16. Now before we carry on, let's just see if our answer makes sense. Remember we said our height here was at 25. So it makes sense for this to be at 16 because it's below that point. Okay, so you should always test your answers and see if they make sense. Okay, let's now find the y-intercept of the exponential. Okay, so 2 times y is equal to, let's make that meter, y is equal to 2 times 1/2 to the power x plus 1 minus 4. X plus 1 minus 4. Okay. So now in place of x, I'm going to put 0. So 0 plus 1 is just 1. And you can take the 1 away because it's the same thing, right? So the 2 times half is 1. 1 minus 4 is minus 3. Okay. So therefore, B is at 0 and minus 3. Okay, and again that makes sense because it's above our minus 4 line here. Okay, so this is 0 and minus 3. Another thing to keep in mind is that with exponential graphs, the y-intercept will always lie exactly 1 unit above the asymptote. Okay, so then in this case this was at minus 4, so this lies at minus 3. Okay, so we didn't even need to do a calculation, you can just state that, but if you're unsure you can just calculate it and you'll get the right answer. Okay, so now let's see, the question actually asked for the length, so all you have to do is subtract it. So therefore EB is equal to 16 minus minus 3, which is 19 units. Okay, cool. Let's look at 6.5 now. Determine the values of x for which f is decreasing. Okay, so if you look at f, that's our parabola. I'm just going to get rid of this for now. If we look at our parabola, we have 3 points that it can basically be, right? It's either increasing, decreasing, or stationary. So at our turning point, our graph is always stationary. Okay. And with this downwards facing parabola, everything before that point, so everything up until that point, the graph is increasing. Okay. And everything after that point, the graph is decreasing. Okay, so this is the decreasing part. Okay, decreasing, and this is the increasing part. So the question is saying determine the values of x for which it's decreasing. Okay, so it's decreasing whenever x is greater than 3, right? Because it's moving in this direction then. Okay, so that's our answer then. When x is greater than 3. Okay, let's now look at 6.6. It says calculate the average gradient between points A and B. Okay, so point A is the x-intercept of f of x, right? And point B is the y-intercept of the exponential graph, and we already found that coordinates. It was 0 and minus 3. Okay, so our job is now to just find A. Okay, so let's do that. So x-intercept y equals to 0. Okay, and our equation is minus x minus 3 squared plus 25. Okay, so 0, or let's start here, y is equal to minus x minus 3 squared plus 25. Okay, now I want it where y is equal to 0, so I'll just replace that. Okay, and now let's solve. Okay, so I'll bring minus 25 on this side, and we have minus x minus 3 squared. Okay, let's get rid of these two negatives, so I'll divide both sides by negative 1. Okay, let's find the square root of 25. Now remember, this can be plus or minus 5. Okay, so x minus 3 is equal to plus 5, or x minus 3 is equal to minus 5. Okay, so that means x is either equal to 8, right, if I bring that to that side, or x is equal to minus 2. Okay, so this is obviously, so a is going to be at minus 2 then, right, because it's on this side of the y-axis, and then this is going to be at 8 and 0. Okay, so we can state that therefore a is at minus 2 and 0. Okay, and we already knew b was at 0 and minus 3, right? And the question says the average gradient between that. So the gradient of AB is equal to change in y over change in x, right? So let's take our two y values, minus 3 minus 0 over, and now let's look at our two x values, over 0 minus minus 2. Okay, and that gives us minus 3 over 2. Okay, so that's our final answer then. That's our average gradient. Okay. 6.7 says graph T is obtained by reflecting G. G is our exponential graph about the x-axis. Write down the range of T. Okay, again, range is our y values. Okay, so we took graph G, which was our exponential graph over here, right? And we reflected it, about this x-axis, right? So how is that going to look now? So you can imagine that if I took this point and I moved it here, let's say, right? Because I reflected it there. And then I took this point here and I moved it there, right? And then I took this point and I moved it there. So you can see it's all getting reflected. Now let's draw out that line, how that's going to look. It's going to look something like that, right? So our asymptote now goes there. So where initially it was minus 4, now it's going to be plus 4. Okay, so our range then is that x is less than 4. Okay, so to write down the range of t, the range of t is that y is less than 4. Okay, cool. And let's just write down what the graph of what t of x actually is. So t of x is equal to, so it's the exact same part. The first part is exactly the same, right? 2 times 1 over 2 x plus 1. But now instead of saying minus 4, we're going to say plus 4. Okay, so that's how we got to that point there. Okay, 6.8. If p equals to f of x plus 2, write down the coordinates of the turning point of p. Okay, so let's think about this now. 6.8. F of x was minus y is equal to minus x minus 3 squared plus 25, right? Now if I add 2 to that, right? If I add 2 to that, to f of x, I'll get plus 27. Okay, so I just took 25 plus 2, that's 27. Now remember what I was saying earlier about this being the turning point coordinates, right? So the new turning point now is going to be at 3 and 27. Okay, 6.9, determine the value of k for which the straight line y equals to 2x plus k will be a tangent to f. So remember, a tangent is just any point, any line that cuts the graph at exactly one point. Okay, so it does touch the graph, but only at one point. So that means at some point they are equal to each other. So we can start off by equating f of x to that line there, right? So what is f of x? F of x is minus x minus 3 squared plus 25, okay, equals to, and now we equate it to that, 2x plus k. 2x plus k, okay? Let's square our binomial here, so x squared minus 6x, because I multiply them, so that gives me minus 3x, and then I double it, so minus 6x, plus 9 plus 25, and then I'll bring these terms to this side, so minus 2x minus k equals 0, okay? So this gives me minus x squared plus 6x minus 9 plus 25 minus 2x minus k equals 0. Let me group my like terms and add them. So plus 6 minus 2 is plus 4x. And then minus 9 plus 25 is plus 16. And then minus k doesn't have any other terms, right? So what do we have here now? Here we have a quadratic equation, right? And how do we find? So if we want to find the points where the two graphs are touching, remember the roots are going to be equal at that point, okay? Because they only touch at one point. So that means both. If you take a normal parabola, right? Let's say I take this parabola, and I draw any other line. Let's say like that, right? I'll find 2 points of intersection, okay? But with a tangent, I only have 1 point of intersection, okay? So that means that the roots, because there has to be two roots, will be at the exact same point, okay? So there's equal roots, okay? So to do that, to get equal roots, we have to equate our roots to 0. So delta b squared minus 4ac, that's how you find the roots, the nature of the roots. So if we equate this to 0 now, that's where we'll find the point where we have equal roots. Okay, so b squared, so 4 squared minus 4a is minus 1. And then c is this entire term here, two terms, okay, 16 minus k equals to 0. Okay, 16, because I just squared 4, plus 4 times 16 minus k equals 0. Okay, so 16, 4 times 16 is 64, so plus 64 minus 4k equals 0. Okay, 16 plus 64 now is 80, so 80 equals to 4k. Alright, I just moved this to that side. So therefore k is equal to 80 divided by 4, which is 20. Okay, so that's the answer then.